In this video, I am going to show you how we can configure complete ISIS scenario. As you can see here, we have a scenario include three areas, area 1, area 2, and area 3. In these three areas, we have level 1, level 2, and also level 1-2 routers. I want to show you how you can configure it, and finally, we can check the connectivity between loopback interfaces of router 4, router 5, router 6, and router 7. As you can see, router 1 is a level 2 only router, router 2 and router 3 are level 1-2 routers, and router 4, router 5, router 6, and router 7 are level 1 routers. I configured IP addressing previously, and you have this configuration in this text file. I want to start configuration of ISIS in this scenario. As you know, we can start from the router 1. Router 1 is a level 2 only router, and you know that in previous videos I configured level 1 and also level 2 routers. By default, a router is level 1-2 router in Cisco iOS. Because of that, if you have level 2 only router or level 1 only router, you need to configure them. But if you have level 1-2 router in one scenario, you don't need to configure it because the default status is level 1-2 router. Let me to start with the router 1, enable, configure terminal, and then router ISIS like the previous scenarios. After that, we should configure net address. The net address of router 1 can be 49.0.0.0.1, and after that quad 0, quad 0, 0.0.0.1.0.0. And after that, IS type, here you should configure IS type. We have three conditions, level 1, level 1-2, and level 2 only. The default is level 1-2. Let me to configure it as level 2 only, and after that log adjacency change all now is enabled. And then we can configure interface serial 10 with the IP router ISIS, and then interface serial 11 IP router ISIS. Here we have one important note. Because you configured router 1 as the level 2 only router, when you configure IP router ISIS in one interface, it means that I want to enable only level 2 ISIS on this interface. Why? Because this is level 2 only router and it doesn't have level 1 database, or it can't establish level 1 adjacency with other routers. Why? Because this is level 2 only router. Let me to configure the router 2. The router 2, as you can see here, is level 1-2 router. Because of that, the IS type is not necessary, is not mandatory to configure. But it's better to configure each interface as level 1 or level 2. It means that, for example, on serial 10, I want to establish level 2 adjacency. In serial 11 and serial 12, I want to establish level 1 adjacency. If you don't configure each interface as level 1 or level 2, it means that on each interface, the ISIS tries to find both level 1 and level 2 database, or level 1 and level 2 neighbors. And because, for example, on the serial 11, we don't have any level 2 router, actually you are wasting the bandwidth and other resources like CPU. Why? Because router 2 should send the level 2 hello, but the router 4 is level 1 only router, and it means that you are sending ISIS level 2 hello for nothing. Because of that, when you have level 1-2 router, it's recommended to configure the interfaces as level 1 or level 2. Let me to configure the router 2. Enable, configure terminal, and then router ISIS. And then let me to configure net address 49.0.0.0.2. Then quad 0, quad 0, 0.0.0.2.0.0. IS type is level 1-2, and this is default, but let me to configure it again. IS type level 1, then 2. That's it. Okay. And after that, log adjacency change all. And then interface serial 10 IP router ISIS. Actually, with this command, we enable ISIS on this interface. But with this command, ISIS circuit type, you configure the level 2 only actually ISIS on this interface. It means that please try to find only level 2 neighbor. Here we don't have any level 1 neighbor. It is recommended from performance view. After that, now as you can see, we have level 2 router, level 2 neighbor on this interface serial 10. I will show you with the show ISIS neighbor command. And then let me to configure serial 11 with IP router ISIS. Okay. And then ISIS circuit type here. Now we have the level 1 circuit type. You can configure level 1. Okay. Or level 1, 2, level 2 only. Default is level 1, 2. Let me to configure level 1. That's it. And then on the interface serial 1, 2, on this interface again, IP router ISIS circuit type, okay, is level 1. That's it. Let me to show you the neighborship that now we have in the router 2. We expect to see only one neighborship because I didn't configure router 4 and router 5. Let me to show you show ISIS neighbors. As you can see, we have one level 2 neighbor on the serial 1, 0. Then we should configure the, for example, router 3. In the router 3, here we can start with the configure terminal, then again router ISIS, net address is 49.0.0.0, for example 3, then quad 0, 0.0.0.0.3.0.0. That's it. IS type is level 1, 2 because of default. This is default. It is not important to configure it. Here I'm going to not configure it. After that, log adjacency change all. Then interface serial 10. ISIS circuit type is level 2 only, and then IP router ISIS. Now we will have neighborship between the router 3 and router 1. Okay, and then interface serial 11 IP router ISIS circuit type is level 1. Only in the level 1, 2 routers we should configure ISIS circuit type on the interfaces. And then interface serial 1, 2, again IP router ISIS, IP router ISIS circuit type is level 1. That's it. And then let me to configure the router 4. In router 4, because this is one of the routers in the area 49.0.0.2, we should configure actually same area ID between the router 4, router 2 and router 5. The router 4 and router 5 are level 1 routers of this area, and router 2 is the level 1, 2 router of this area. In the router 4 actually we should configure first enable configure terminal, and then router ISIS net address is 49.0.0.0 for example 2, then quad 0, then 0.0.0.4.0.0. And then here we should configure IS type as level 1 because default is level 1, 2, and then log adjacency change all. And then interface serial 10 IP router ISIS. Here we don't need to configure ISIS circuit type. Why? Because the router is level 1 only router, and it doesn't need to configure the interface to level 1, because when we are in level 1 only router, it means that it is mandatory, it is obvious that all interface of that router is or are the level 1 interfaces. And then here we have interface loopback 0 IP router ISIS. That's it. In the router 5, the next router, enable configure terminal router ISIS net address 49, then 0.0.0.2 quad 0, and then 0.0.0.5. Okay, then 0.0. IS type is level 1. Then log adjacency change all. Interface serial 10 IP router ISIS. Interface loopback 0, again IP router ISIS. The next router is the router 6. This is router 6. Enable configure terminal router ISIS. And after that, net address is 49.0.0.0.3, again quad 0, 0.0.0.6.0.0. And then IS type again is level 1 and log adjacency change all. And after that, interface serial 10 IP router ISIS, interface loopback 0, again IP router ISIS. And the last router is the router 7. Let me to configure it also. Configure terminal router ISIS. Net address is 49.0003. Again, quad 0, 0, 0, 0, 0, or for example, 7.00. And then IS type is level 1. Log adjacency change all interface serial 10 IP router ISIS. And then interface loopback 0. Again, IP router ISIS. Now we can check first the neighborship and after that connectivity between the routers. First, in the router 1, this router, we expect to have two level 2 adjacencies. Show ISIS, and then neighbors. Here, for example, as you can see, we have two neighbors, router 2 and router 3. We have level 2 adjacency on the serial 10, serial 11. Then in the router 2, show ISIS neighbors can show us we have three neighbors, one level 2 neighbor, router 1 on the serial 10, and two level 1 neighbors on the serial 11 and serial 12 respectively, with router 4 and router 5, as you can see here. And then in the router 3, the next router here, show ISIS neighbors, can show us we have again three neighbors, one level 2 neighbor, router 1, and two level 1 neighbor, router 6 and router 7, these two routers on the serial 11 and serial 12 respectively. And finally, in the router 4, show ISIS neighbors, we have only one level 1 neighbor. And in the router 5, show ISIS neighbor, again we have only one level 1 neighbor, router 1, router 2, router 5 and router 2. And then in the router 6, show ISIS neighbors. As you can see, we have neighborship with the router 3. And finally, in the router 7, show ISIS neighbors, we have actually, as you can see, one neighbor, router 3. Then let me to show you the routing table of router 4 and router 5. We expect to see the level, the routes of this area inside of the routing table learned from the ISIS or connected networks. And also we expect to see one default route received from the router 2. Okay, in the router 4, this is the router 4, show IP route ISIS, can show us we learned quad 5/32 with ISIS, okay, ISIS level 1 actually database, and also 10250/24 from ISIS means this network. In the router 4, we have this network and also this network. And also we expect to see one default route learned from the ISIS, okay. And you know that we are learning this from some bits, as I explained them in the, for example, in the complete course. Here you can see IL1 quad 0/0. It means that everything is okay in the router 4. In the router 5, show ISIS neighbors, again, or show IP route ISIS. As you can see, we have quad 4/32 in the routing table of router 5, this network, IL1, and also 10240/24, this network in the router 5 again. And also we learn one default route from the router 2, the level 1 router. Actually, as you know, in ISIS by default, in normal condition, we learn only the networks of the inside of area with ISIS, and also the one default route from the level 1-2 router of that area, or multiple default routes if you have multiple level 1-2 routers on that area. In the router 6 and router 7, we expect to see the similar condition. Show IP route ISIS. In router 6, as you can see, we have quad 7/32 and also 10370/24 this network. We learned them from the ISIS, and also one default route from the border router, the router 3. And then in the router 7, show IP route ISIS. Again, we have quad 6/32 and also 10360/24 and finally one default route. But in the router 1, you know that this is router 1. Router 1 should has all of the networks inside of this scenario, okay, and all of them should be L2, okay, because the router 1 actually is a level 2 only router. And you know that each area border router, or actually each of these router 2 and router 3, should advertise or should inject automatically the level 1 networks of their area, okay, into the level 2 database. Let me to show you. In the router 1, show IP route ISIS can show us that we have quad 0, quad 4/32, quad 5/32, quad 6/32, and quad 7/32, and also some of networks of the links. And after that, here, if you want, you can check show ISIS here database. Okay, in the database of router 1, we have only actually this is the only level 2 database. Why? Because here we the router 1 is a level 2 only router. The database or LSP received from the router 1 itself, from the router 2, and also from router 3. And in the router 2, okay, we expect to see two database, one level 1 and one level 2. Show ISIS database. As you can see, this is level 1 database, include the LSPs received from the router 2, from the router 4, and router 5, and the level 2 database received from the router 1, router 2, and router 3. Also, in the router 3, we have similar condition, show ISIS database. Both level 1 and level 2 database exist. And also in router 4, router 5, router 6, and 7, we expect to see only level 1 database, show ISIS database. As you can see, we have level 1 database, include LSPs received from the router 2, router 4, and router 5. And also in the router 5, we have similar condition, show ISIS database. We have actually level 1 database received from the router 2, 4, and 5. In the router 6, as you can see, show ISIS database. We have a level 1 database received from the router 3, router 6, and router 7. Exactly in the router 7, we have similar condition, show ISIS database. All right, now let me to check connectivity between the loopback interfaces of the router 4, 5, 6, and 7. In router 4, let me to use ping quad 5, and then with the source of loopback 0, you know that this is intra-area network. And as you can see, we have connectivity. With inter-area networks, ping quad 6, with the source of loopback 0, again we have connectivity. And also quad 7, with the source of loopback 0, again we have connectivity. For example, you can check from the router 7, this is the router 7, here, ping, with the ping quad 4, with the source of loopback 0, or ping quad 5, with the source of loopback 0. Also, you can use trace route. Trace route, for example, quad 4 with the source of loopback 0. Traffic will go, here it's better to use numeric. Let me to try from router 6. Trace route to quad 4 with the source of loopback 0, numeric. As you can see, traffic from router 6 will go to the router 3, and then router 1, and then router 2, and then router 4. You know that we can reach to the router 2 with default route, and from router 2 with the networks that we learned from level 2 database, we can reach to the router 3, and from router 3 to router 6 we can reach with the level 1 information. Actually, in this scenario we learned about level 1 and level 2 and level 1-2 routers configuration. In level 1 and level 2 routers, we don't need to configure ISI circuit type, because when we configure a router as level 1 or level 2, it means that all interfaces are level 1 and or level 2 respectively. But in level 1-2 routers, we need to configure ISI circuit type on each interface, and we should say which interface is level 1 interface or level 2 interface or level 1-2 interfaces.